Hello students, I'll be doing chapter number 4, Simple Machine. Now see here, our first topic is work. So what is work done? Like when we can say that we have done some work. By now, from after we wake up in the morning, we do a lot of work, right? Now you see, I'm writing some examples. Now you see in the first one, what I've written walking on the road. Now you see, for example, if I'm standing here, now from here I've started walking, right? So initially I was here, right? And then you see I went till that place. So this much distance I have moved my body from here to there, right? So you can see that I have moved some distance from here to there. So in that case we can say that we have done some work. But now you see in example 2, for example, I'm standing here carrying a bag. I'm just standing here, I'm not moving. I'm not moving from here to anywhere, right? So in that case, no work is done. Though the bag is very heavy, you are carrying it. But there is no work done. Why? Because there is no displacement of distance or there is no change of shape. So in the first case, since there is a displacement of some distance, I'm moving some distance from one position to the other position. The position is changing, right? So in that case, we can say work is done. But in case of example 2, you see I'm not moving from here, I'm just standing here with the bag. In that case, no work is done. So what do we understand from here? Whenever there is any change, for example, if it's a change of place, it's a change of shape. For example, if I'm pressing a rubber band, so you see there will be a change in shape, right? There, the shape will change. In that case, I can say that work is done. And in number 2, where there is no displacement, in that case, no work is done. So from here, what do we understand about the definition of work done? Work is said to be done So from this definition, what do we see? Work is said to be done when a body moves. For example, in example number 1, I was walking from some distance to the other point. So I'm moving my body. In that case, work is done. And the other is when change is position and or shape. So if any change is there in case of position or in case of shape, in that case we call work is done. For example, you see when we ride a bicycle, we are moving right from one place to the other. In that case, work is done. Then if I am pressing something, in that case also work is done. Why? Because when you press something, it changes the shape of that object. For example, if I have a piece of a paper which is very fresh, but when you scramble it, when you press it or squeeze it, it changes the shape, right? In that case, some work is done. Next is energy. Now, what is energy? You see, energy, it gives you the ability for doing some work. For example, walking or running might be better. So you see what happens when you run a long distance. So initially when your body is at balance, in that case you are starting, right? So you have a lots of energy to run or to walk. So after some time what happens from here to where you still have that energy, you still run. But what happens when you keep on going? Your speed gets slow, right? You run, then you keep on running in a low speed when from here to there, when you keep on walking, right? Sorry, keep on running. So in that case, when you keep on running, after a certain point, you see by the time you reach here, you get tired. Why so? Because when you are running, in that case, you need energy. So whatever energy you have in your body, you're using that energy, and as a result, you are running from here to there. So in that case, in case of running, what you're doing, you are using the energy. In that case, is the energy that is giving you to run from here to there. So if there is no energy, for example, if you're so tired, in that case, will you be able to run faster from here to there? No, no. You'll get tired, you feel tired, so you won't be able to run faster. So in that case, you will run slower. So we see we need energy to do any work. So energy is the ability that let you to do work. So here I'm writing the definition of energy. So energy is the ability, it gives you the ability to do any work. So higher the energy, you'll be able to do the work more nice way. So it needs energy, needs energy for doing any work. So it is the ability that gives you to do any work. So next you see, we'll be doing machine. All this definition is already there in the book, so you can copy from there also in that case. Now what's machine? See, in our day-to-day life, we use a lot of machines, right? Even blade or scissor, even a piece of blade that we use for cutting not vegetables like paper or anything, even that is also a machine. So what is machine? Machine is a thing that reduces the effort needed. Now you see, for example, in your book you can see that machine they have divided into two parts. One is simple machine, the other is complex machine. Now simple machines are those machines where there is not much screw and all those things, and complex machines are those where we use some extra all these elements to make it. For example, blade you see, it's a simple machine. Then even scissors also, it's a simple machine, right? See, in bicycle wheels, there is some more extra part. It's not a single piece of thing. So in that case, bicycle wheel, we consider them to be complex machine. And simple machine, for example, blade, scissors, those are things that we consider them under simple machine. Now here, we won't be learning this one. We'll be learning only about simple machine. So now you see, under the simple machine, what are the things we'll be learning? We'll be learning there are 5 types of simple machines are there that is considered in your book. So here you see, we'll be learning in this chapter about these 5 simple machines. Lever, inclined plane, wedge, pulley, and wheel and screws. These are the 5 simple machines that we'll be learning here in this chapter. Now before we learn about these simple machines, you need to understand the mechanical advantage. So what is mechanical advantage? And one more thing, always remember in simple machine, the energy that you will the force, it needs some force. Simple machine, it cannot work of its own. You need some force to apply on it. So after you apply some force on that, it gives you some work done. It gives you some more force that we consider to be effort. For example, you see here, suppose this is a machine, right? So in this machine, when you put some effort, now what is effort? Effort is also a force. These both are some kind of force. Now, when you put some force on this machine, which we call it to be effort, after you put some effort on this machine, it gives you some output, right? It gives you some output which we call it to be load in that case. So any simple machine, it does not work of its own. We apply some effort, we apply some force in it, and as a result, as an output of it, it gives you some work. It gives you some work done which is some in form of force, which you call it to be load. Now I'll write one formula. You should note down the formula over here. Mechanical advantage we represent by MA. So what is mechanical advantage? Mechanical advantage is nothing, it's the ratio. Ratio of what? Ratio of load by effort. So now you know what is load, what is effort. Effort is the force that is applied to the machine to make it work. And load is the force that you get as an output after that effort is put on the machine. So using all this mechanical advantage, we can find how? Load by effort. We represent it by L. This one is represented by E. So mechanical advantage is, it's a ratio of load and effort. You can note down the formula. You will need this formula to solve next. So we'll be using this formula to solve one question now. I'm writing this formula over here so that in case you forget, you can use it from here. Let's solve a question now. Now, if you read the question, they are asking you to determine the mechanical advantage. And what is the formula to find mechanical advantage? Load by effort. And what else is given? They are asking you to find the mechanical advantage of a simple machine which lifts a load of 50 kg. So here they give you load equals to how much? You see 50 kg. Load is of 50 kgf and effort is of 10 kgf. So to put in the formula for finding mechanical advantage, what do I need? Load by effort, right? That's what I need, load by effort. So L is how much? Load is how much over here? 50 and effort is how much? 10. So if you put, you get 5. So mechanical advantage is how much from here we see? 5. I'm writing the information over here that is given. Since there is no place. So if you read the question, you can see that they are asking you to find the mechanical advantage and they gave you load, they gave you effort. And we know the formula, mechanical advantage. How do we find mechanical advantage? Load by effort. So load is given 50, effort is given 10. You put in the formula 50 by 10, it is 5. So mechanical advantage is 5. So you can find the answer this way. If you get some question from here, you can copy the problem. Okay, so after you do this one, I'm giving you one question you try to do at home, which you are already doing at home. So I think here in this problem there is no questions. It's very easy one. Next question, I'm giving you one more question. You try to find the answer of that. Try to solve it. And if you can't solve it, I'll solve it in my next class. After this question, I'll end it here. Okay, so this is the question. I'll explain in the question. The mechanical advantage is given C4, and they're asking you is to find load. They're asking you of how much load should be lifted by it if effort of 20 Newton should be exerted. So you see mechanical advantage is given. Mechanical advantage is given over here. Effort is also given over here. So all you have to find is load. So how do you find load? There, here is the formula. Mechanical advantage is given, effort is given, you put it in the formula and then you find load. So here I end the class. If anyone have any queries later when you watch it, you can ask in the next class. Thank you.